Hello and welcome to AI Learns to Drive Around a Track. Specifically, what I mean here is that each agent here, each vehicle, has a neural network controlling its motion. So it has 8 inputs, and I'll show you those in a second, which then it controls its outputs, being forward, reverse, left, right, in order to go around a track. And then through each successive generation, the best performing agent vehicles will pass on their learned behaviors to the next generation. So let's take a look at the inputs here. First, on my website here, I've got links to various projects I've been working on over the last few months. I need to update it with my robot simulator. But here, under the Autonomous Vehicle Neuroevolution on the project page, I have a bit of an example demonstration here of the sensors. Let me pop it out real quick. So here, each vehicle has 8 raycasted sensors, which show the distance between the vehicle and any obstacle. So as it moves around, it will report, the distances for each side of the wall of the track. And then the neural network will learn through successive generations to coordinate its inputs to its motion. So how is it passing along this learned behavior? Well, as the vehicles are moving around the track, here let me turn on drawing of the sensors and the point gates. It's passing these blue lines. As it passes a blue line, each vehicle, each agent will get more points. And as that increases, so does each agent's fitness function. And the genetic algorithm uses that fitness function to determine which neural networks to pick to then provide those behaviors to the entire rest of the next generation. And that's how it works in a nutshell. If you're interested in a detailed explanation of neuroevolution, definitely go check out Coding Train. He's got a whole series of videos on neuroevolution. I'll put a link into it below. Okay, let's do a run through here. I just refreshed the page, so it's starting out with a blank slate. It generally takes, I think when I put here on my website, generally takes around, initially taking around 50 generations, but what I've learned over the past few months, I've been able to cut it down to around 20 to 25 generations. So I'll let it run. I'll probably cut at a few points because, as you'll see here in a second, it'll take several generations to start making the first few turns. So to make the first turn itself here, it could take anywhere up to 5 to 7 generations, and then it generally then will get stuck at the next turn, which could take another 5 to 10 generations. So let's let it go. And here we are at the final lap. Generation 27 took a little bit longer than I thought, but I did have to decrease the pop size and the network size a little bit because the video capture software was kind of dragging down the machine. So here we are getting past the first two hard turns and the right turn here, coming up to the sharp turn, which was another big problem. So most of the generations died off at that right turn and then this sharp turn here. But once it figured it out, this next generation here. So I'll come around here and I will save the network. Okay, so I saved the neural net from the previous track, the best player that was able to complete the whole track. I took the file, copied it here. Let's start it up. Oops. Here we go. So here's the alternate track. As you can see, it's starting out from nothing. They're just randomly running around. So let me hit load. The neural net has been now loaded to each one of these agents. Now typically, actually it might just work. I was going to say the first generation usually just dies off at one of the turns. And then the next generation, here we go. There we go. So now it should be able to completely run through the track without a problem. Let's let it run and see. So this is a neural net that was trained on the first track and then has been loaded onto this track, and this is the first time it's seeing it, and it is able to complete it. So all of the training occurred on one track, and we're testing it now on this one. And it completes it without any further training. So that was the whole goal of the project, to first get an agent to be able to navigate through a track just using its neural net to take in the sensors and control the output, and then be able to take that and put it onto a new track. So this was one of my favorite projects. I learned quite a lot doing it. It was one of the most ambitious one that I've done at the time. I've since then gone on to create a robot simulator, an industrial robot arm that starts at nothing, runs in a browser, and learns how to coordinate all its axes to pick and place. Check that out. I have a video here on this channel, and I'll post that up on my webpage as well. Thank you very much.